All right, let's try this. First, free body diagram this sucker. Not great. Let's try that again. That's weight 50 newtons. Normal tension. Net force is 0. So now, let's see, I'm going to use a coordinate system. How about this one? Positive y, positive x, and this is 30 degrees. So, wrap myself a triangle, something like that. This one will be 50 cosine 30. This one's 50 sine 30. And let's do it. Net force in the x direction equals 0. So 50 sine 30 minus tension equals 0. So that's going to be tension equals 50 sine 30 is 25 newtons. Of course, net force in the y direction also equals 0. That's going to be normal minus 50 cosine 30 degrees equals 0. So normal equals 50 cosine 30. Cosine 30 is 0.866. So normal equals 43 newtons. Done. Check. If the cable were to break, what would be the acceleration of the system? Well, if the cable were to break, there would be no tension force. So tension goes away. Also, though, if the cable were to break, the system is no longer in equilibrium. I get MA here. So, how does that change this? It means 50 sine 30 equals M, which is 5 times A. So A equals 10 sine 30, or A equals 5 meters per second squared. Yippee, that's the new answer. Check it off. If instead the block slides down the ramp with an acceleration of 2 meters per second, what is the size of the frictional force in the block? Well, get rid of all that, because now there is an acceleration. It equals ma, where that a is 2. Also, although there is no more tension because the cable has broken, I am being told there is friction. And I think the friction is going to be less because it's accelerating, but not very much. So I'm going to say that's the friction. So minus friction equals m times a. There it is. 25 minus friction equals 10. So friction must equal 15 newtons. Done. Check. Next slide. What is the tension in both ropes holding the 10 kilogram box in place? Alrighty, well, I know this is a little unconventional, but boom. I have tension that way, tension that way, weight that way. Let's see, 10 kilogram box, so this is 10 times 10 or 100 newtons. You know, there's a couple ways to do it, but I'm just going to put the coordinate system like this. And that means that's 30 and that's 30. So, look, I'm just going to do one side because both sides are more or less the same. Either way, the net force is 0. So if I say weep, weep, like that, and like that, this top one has got to be T sine 30. And the side one, it's got to be T cosine 30. So the net force in the x to the, that's hard to read on the white, so let's do blue there. Net force in the x direction equals 0. And I'm making this the x direction. Look, I've got one of these, and there's one on the other side that does the same thing. So that's going to be t sine 30 minus t sine 30 equals 0. That doesn't tell me very much. However, in the y direction, net force, the y direction equals 0. That's this sucker right here. And there are two of them, one for each side. So t cosine 30 plus t cosine 30 minus 100 equals 0. So 2t cosine 30 equals 100, or t equals 100 over 2 cosine 30. What does that equal? Based on my handy dandy calculator, T is 58 newtons. Done. What is the tension in both ropes? They're each 58. And now this one. I know this one probably is making many of you crazy. But remember, the person in the bucket are an object. How many forces act on that object? Well, there are 2 ropes pulling up on the bucket. And it's the same rope that goes from here to there. So I'm thinking it's T and T on that side. Moreover, there is one downward force. The person, 600 newtons. That's it. Those are the forces acting. When it's moving upward at 2 meters per second, net force is 0. So T plus T minus 600 equals 0. So 2T equals 600, or T equals 300 newtons. All right, let's do it again. But now, the upwards force is no longer 0. It's accelerating upwards at ma, which is 2. So this equals 60 times 2. You can't really read that. Let's try that again. Let's just erase all of that and redo it kind of neater. So net force equals 2T minus 600 equals 60 times 2. So that means 2T minus 600 equals 120. So 2T equals 720, or T equals 720. It's going to be 360 newtons. I better pull on the rope with 360 newtons of force, and I rise into the air like like an amazing guy in a basket. Next. Just kind of let it sit here for a few seconds. Okay, now, the only difference is now the acceleration is downwards. So, if I could just totally make that better. 60 times negative 2. All right, that's all there is. 2T minus 600 equals negative 120. So 2T equals 480. So T equals 240 newtons. Woot woot. What would be the tension in the upper rope for each case? That's talking about this rope. Alright, so there's 3 ropes. There's the tension upwards in that rope, and there's 2 tensions downwards, T and T. This is, we'll say, T upper rope. Does the pulley thing ever go anywhere? No. So the net force on the pulley is always 0. So in the first case, it's TU minus 2T equals 0. And in the first case, T was 300. So TU equals 2 times 300. And lo and behold, the upper rope holds all 600 newtons of the bucket. All right. It is always net force equals 0. The only thing that changes is this number. So when it's accelerating upwards, this becomes 360. That's 360, and 2 times 360 is going to be, not a surprise, 720. So when it's accelerating upwards, the cable has to hold the net force on the bucket. You know, that's going to tell me something. When it was accelerating downwards, the net force on the bucket was 480. So we know when it's accelerating downwards, it's going to be 480. Yeah, that was pretty fast, but yeah, that's me. I know what I'm doing. All right, last one. A boy drags a 1 kilogram toy across the beach using a 10 Newton force as shown. Great. If the toy is moving at a constant velocity, what is the size of the frictional force acting on a toy? What is the size of the normal force acting on a toy? All right, so this is the easiest one that you were given. Let's go with free body diagram. There is let's put it right here. There is this force, which we are told is 10 newtons. No one can see that, so let's make it 10 newtons. There is this force, which is, it's a 1 kilogram toy, so it's 10 newtons. There is an upward force from the ground. That's the normal force. And then there's friction. Can't really see that one, so let's do it in red. Friction. That's really ugly. Friction. There you go. Alrighty. I'm going to break up the one off axis. I mean, the axes are pretty obvious. It's going to be this way. And up here, that's positive y, and this is positive x. So I'm going to wrap the triangle this way. This will be 10 cosine 25. This one, 10 sine 25. And let's see. Net force x direction equals 0. Why? Constant velocity. So what do I got? I've got 10 cosine 25 minus friction equals 0. Net force in the y direction, I got 3 of them. That's right. 10 sine 25 plus normal minus 10 equals 0. So question 1, solve for friction. Friction is 10 cosine 25. So friction equals 9.1 newtons. So now normal equals 10 minus 10 sine 25. So that's going to be normal equals 5.8 newtons. That's it. Now it's weird to have the frictional force be bigger than the normal force, but this is just a contrived problem, so yay, you're all done. All right, go to bed. Enjoy. I'm just kind of talking now so you can have a chance to look at that because, you know, it's hard when I'm so awesome and all that kind of stuff. Good night.